Erik, the floor is yours. Go ahead.
Perfect. Make sure this thing's working. There we go. Well, good morning, everyone. It's always interesting to see who shows up to the first session on the last day, because these usually precede kind of the big night out or the social event. So I think we were supposed to, as I was walking up, check the app, it said we were supposed to have 90 attendees. Like, there's no way that's going to happen based on every conference I've ever been to. But appreciate everyone being here this morning. My name is Erik Wallace. I'm one of the healthcare life science product managers in Google Cloud. You've heard from Vivian, a teammate of mine, and a few other Googlers throughout the week. I'm really excited to be here. This is my first DevDays. It's my first exposure or involvement in the community, so everyone's got to be nice throughout this presentation. But it's been really an enlightening week just to really see what this body is all about. It's been really neat to see how everyone contributes to kind of a single mission, single driver, and really how thoughts get formulated, surfaced, and really just discussed. So again, for me, it's been a really, really neat week. I'm accompanied up here by Chris, who I'll let introduce himself.
Good morning, everyone. I'm Chris Grenz. I am a product manager similar to Erik and Vivian in Google Research and Google for Clinicians. And I'm just going to fill in a few of the spots here on some of the things that we've been doing in analytics and some of the things we're thinking about in this space. And first time at DevDays myself. I've been around the community though for quite a while. I've been with the working group and glad to be here.
Great, so just a quick overview of where we're going today. So today's topic is really in and around how we drive insights into your FHIR data. And we're going to be talking about that in a few different ways, from like that foundational analytics lens, some ML lenses, and AI lens. And obviously that's been one of the hot topics of this entire week. And kind of in listening to these different discussions that have taken place, in talking to our customers, understanding how to drive efficient, usable insights into FHIR data has just been a consistent theme and a consistent challenge across the entire industry. And today's really about three things for us. An overview of how we at Alphabet think about this problem and how we frame it. Some common approaches and methodologies we're applying to help customers really make their FHIR data a little more usable and user-friendly. And then thirdly, a demo of how we've actually brought a few of these themes that we'll review with you together that we actually have out in the field and they're being used by customers today. And for those that caught Vivian's speech yesterday, I think she said it pretty well, is that a lot of this work that we're doing in the analytics space, and I'm sure this is going to be a relatable comment to everybody here, we like to think these as really science experiments where we deploy, we listen, we learn, we iterate quickly based on feedback. Just because, as the working groups have called out, not all this stuff is completely standardized, and we're not aligned on the best approaches for how best to start driving insights and interrogating the FHIR schema, let alone when we have that in an enterprise production environment where we have FHIR data coming in, HL7 data coming in, DICOM data coming in. How do you start doing kind of mass enterprise-wide analytics and ML on top of all that in a scalable, uniform, performant way? So I have this slide up here. This is not meant to be salesy. This is not meant to be kind of showcasing the portfolio, merely bringing this to light because some of these may be referenced throughout the speech. And so kind of at Alphabet, specifically in cloud, we really have two buckets that we're building these technologies in. Accessible APIs and more enterprise-wide solutions like Healthcare Data Engine. And again, won't go into too much detail here since Vivian covered a bit of it yesterday. But each of these serves a unique purpose in our portfolio. And what we're doing here is building capabilities and frameworks like the enrichment framework, which allow these products to actually interact together. You can think of these as really Lego building blocks that can be tailored and curated and customized by customers based on their specific use case. So again, just wanted to bring this up because a few of these do emphasize some of the work we're doing in AI ML, specifically with DID. How do we de-identify patient data as it's coming into our kind of different cloud environments? But then more importantly, depending on the use cases, how do we make that more anonymous, as well as NLP and enrichments? So there are 3 or 4 common themes that we really anchor on and think through as we try to assess how to drive insights into FHIR data. And the kind of these challenge statements that are reoccurring across the industry and from customer to customer that we've seen. And I'll remind you that I am a product manager, so forgive me if this is coming from more of the product to customer lens. We'll get into more of the solution-y tech side here in a few moments. But the first real consistent problem statement that we see and that everyone here is going to be able to relate to is that healthcare data is incredibly siloed and fragmented. Very rare when you're dealing with some of these large customers are you dealing with a single source of truth, a single EMR. Some of our customers have 50 EMRs, 100 EMRs, kind of hundreds of sources that we need to be able to pull from. And all those sources usually have data structured in different ways that have different varying levels of volume that are kind of on different time spectrums in terms of how quickly they're refreshing. So that siloed and fragmented element is incredibly challenging to deal with. I think is one of the foundational principles of why we're here as a FHIR community. That feeds really nicely into this second challenge and second pain point, which that lack of structure and that disparate data makes interoperability incredibly limited, and that standardization very challenging. It makes it very hard to get a common standardization around those data elements aligned. And this is where Alphabet has really chosen FHIR as the standard to anchor on. And so again, all those technologies you just saw and everything we talked about over the course of the week that we're producing, Alphabet's investing heavily in FHIR as the standard of the future, just so that we can enable and start unlocking the value you get with interoperability. And then finally, because of these first two, obtaining a longitudinal patient view, a single view of a patient over time, is incredibly challenging. This is one of the main value propositions that Healthcare Data Engine solves for. But kind of when you have all these three together, and then combined with the fact that FHIR data is inherently incredibly nested, highly structured, very hard for modern day reporting tools to interrogate and sit on top of, it creates kind of big problems in enterprise reporting. And now as we evolve and start looking at how we use generative AI in a similar fashion, it makes kind of driving those insights and sitting those new technologies on top of your traditional enterprise reporting data warehouses a bit limiting. So these are really the 3 or 4 things that we think about as we build technologies and build solutions in around driving insights, analytics, and AI solutions. These next 2 slides are really going to set the stage for what Chris is going to talk about, which is some of the more common everyday approaches that we use to drive analytics and insights. So this frame will probably look pretty familiar to everybody. We stole it from kind of Maslow's hierarchy, put a little ML tech spin on it, which we call the hierarchy of ML needs. And this workflow and journey should look pretty familiar to folks, where you start with your foundation of all of your source data, kind of making sure you have everything onboarded, kind of in a state of usability, secure, compliant, especially when it comes to HIPAA and healthcare data. And from there, we can start striping on top of it, enriching those foundational data sets, bringing in third-party data. We're going to showcase how we do this using BigQuery, which is one of our analytics warehouses here in Google Cloud, and adding richness and depth to that FHIR-based record. From there, once you have kind of that enriched data set, you can start doing joins. You can start looking across different data sets and continue to optimize and tune based on a use case. And then from there, building models, and then models lead to predictions. We get to actually drive insight and take that data, make it actionable, and start seeing some real return on value from your data sets. And so this is the general flow that we apply, and I'm sure a lot of you do as well, as we think about how best to optimize our data, how to increase usability and depth. Last little businessy slide here, I promise, before we get into some of the more technical weeds. This is a templatized framework. This is not anything that we've necessarily built, but what we're showcasing here is a lot of what is in this slide is what Chris is going to be diving into here in a few moments, of how do we take that hierarchy and actually put that into an architecture? How do we take some of those challenge points that we discussed a few moments ago and address them with technologies and platforms? As you're going to notice that this follows the same theme that we just went through through the hierarchy. We establish our infrastructure platform, that baseline data where we do our optimization, we do our data joins, things of that nature. And then one thing we're going to be talking about later, that in terms of lessons learned, because again, these are science experiments, we're always learning best from learning from customer feedback, is based on what use cases we're solving for. We're going to be applying different methodologies of interrogating your data. So some of the ones Chris is about to go over, and we've heard a bit about this week, is the application of CQL. And maybe thinking above and beyond what traditional CQL is, not just using CQL for clinical quality reporting, but are there ways that we can start using this to be a cohort manager, defining and interrogating our FHIR data from our FHIR store? We've talked about Gen AI a bit yesterday. We're talking about kind of leveraging operational databases for analytics, more of our traditional techniques, so that we're not recreating the wheel with the introduction of FHIR at enterprise scales. And then this really unlocks the business value and kind of the user surfaces up top here. But we found, and I'll reiterate this later, that taking this use case driven approach in and around insights and analytics is really the way to go, starting with the problem statement and then working backwards from a tech development standpoint. So with that, I'm going to pass it off to Chris to talk about some of these elements we saw in the architecture and some of the everyday approaches that we apply.
Great, thanks, Erik. All right, so we've been working with FHIR data for quite a while, although it's accelerating more and more all the time. And when I say we, I'm talking about the community as much as anything. And pretty early on, questions came up, as it would. How do I put this in a relational database? How do I take this highly nested structure and put it in a database that looks much more like what I'm used to dealing with, that's much more accessible to the BI tools I'm used to working with, the ETL tools I'm used to working with? And one of the approaches, or one of the things that we came up with early on, and I don't think this is a Google specific thing, is that we wanted to have some sort of flattening capability, some sort of flattening mechanism. And there are a number of libraries out there. There's a Python library out there that does some of this. And this is a really hot topic to today. You know, the SQL on FHIR and SQL on FHIR 2.0, I think is what we're calling it, thinking about how to convert these nested structures. And one of the big nets of all this is that there's no one answer for that. What you're looking for and what you're optimizing for are a critical part of deciding how you want to flatten these things, how you want to make a rectangular table out of a naturally hierarchical table, and what things you want to extract out of it. So this first example here is based, I believe, on our Python library for this. And it basically unrolls some of these into primitives. So we can see the quantity of the observation unrolled to just flat values, the effective timestamp pulled out, and you get a nice rectangular table out of this. It's not very portable, it's not very interoperable, and that's one of the goals of the SQL on FHIR work is, you know, is there value in having this in an interoperable way? But it's functional, and it's something that we've used quite a bit across different customers, and people have found quite useful. The challenges with it, though, remain that, you know, most of these resources have multiple nestings. It's not just that you can sort of unroll one nesting and you're done. So just take patient, for example. I've got contact information, I've got addresses, I've got a number of things that are arrays already. Do I do some sort of cross-join unrolling of all that and end up with, you know, every contact next to every address and then try to figure out what that means? Or do I have different tables for every single array that's in a resource? And frankly, there's not an answer to that problem. That's just a fundamental problem. And being able to pick and choose and quickly develop these for a particular use case is very useful. Downside of that, then, again, is that now I'm unrolling tables, you know, dozens of tables, hundreds of tables in different ways for different use cases. And I've got sort of this explosion of storage and explosion of things. So I don't pretend to have the answer to that, but one of the things that we are thinking about in this space is how can we manage these more effectively? How can we tie this kind of a view or this kind of a rectangular projection to a use case so that you're not managing all of these individually? You're managing your use cases, you're managing perhaps a measure definition or some other conceptualization of a use case, and you just sort of get these things because they're a natural extension of that. So that's how we're thinking about moving forward with this kind of technology. But it's definitely something that's happening right now. There are calls every Friday about what SQL on FHIR 2.0 might look like. And if you're interested in this topic, I would definitely recommend you get involved. You can find the FHIR Analytics Zulip track, and the meeting notices are in there. And jump on a call and just hear what's going on in this space.
Yeah, and just to add one thing in there that was kind of a recent discovery of ours. Like I said earlier, we like to deploy fast, fail fast, and then iterate even faster. Is that we, as Chris said, there's no silver bullet, and this is not kind of black and white, whether we go all flattened or no flattened. And kind of in working with one of our main customers over the past few months, we found that kind of what they're looking for is somewhere in the middle, where this concept of like semi-flattened, where they don't need, they ultimately just need your average everyday SQL user to be able to interrogate FHIR data. So like we don't need a completely cross-join where every row is blown, kind of every column is pivoted into a single row. Some nesting is okay. And so now we're trying to find that happy middle ground of what does that mean? Kind of what fields is that more okay to, where can we leave some nesting within the schema? Where do we have to have it completely flat? So as Chris said, it's an ongoing discovery. It's an ongoing science experiment. But yeah, we're finding that middle ground where it's not all or nothing here, and we're getting some good feedback there.
Oh, looks like I ran through this slide verbally already. One thing I'll add at this point is again, the working group is talking about shareable definitions. So if there is a IG that talks about a particular use case, can we include a shareable flattened view for that? Can we, something that we could, get to the point where we could share then SQL queries, we could share reports, we could share other kinds of things on top of that. So very interested in community feedback on that. Is there value in that, being able to have a consistent rectangular projection for a use case that we would talk about? Or is this really an implementation detail? Is this something that is so specific to how you're using this situation that doesn't matter? It would be pretty tough to think about how US core might carry enough specificity to define these things, because it's very broad. But if you get all the way down to an IG for a particular guideline or a particular HEDIS measure maybe, or something like that, you might be narrow enough to do that, and that might be useful. So definitely think about that. The other thing I would say is that one of the things we've also found valuable is if you're thinking about in your tooling about some of the sort of the fundamental concepts of FHIR, like how do you think about codable concepts? And is your goal to flatten those out and have a column for snowman code, where you just are doing the terminology harmonization, you're doing the translation, and you get a nice single column, and you can go right after it. Or do you need more capability in that? And how do you represent that? Snowman code by itself, because of the ontological nature of SNOMED, dealing with different granularities, dealing with the sort of inherent nature of how things are coded, is also a challenge. So, does there need to be a separate table that deals with all of that? So if I've got, migraine with aura, migraine with all the different possible ways, and really I want to talk about, patients with headaches, I have to do some ontological reasoning as part of that. That's not something SQL does very well on its own. So how do I deal with that? And there's a number of things in FHIR that are like that. The codable concept terminology stuff is the most relevant in most cases, but having a strategy to work around that is pretty important. All right, so CQL. I'm really excited that a ton of content here at DevDays is about CQL. We've been sort of sniffing around this problem space towards the edges of the working group and towards the edges of this community for a long time, and all of a sudden, I think folks have started to figure out that we've got data moving, the regulatory frameworks are in place. TEFCA's coming online in the US. There's going to be more data flowing around. Bulk FHIR is starting to happen, and we've moved from the can we get data to the so what phase of interoperability, and naturally then we have to start thinking about how do we think about knowledge, and how do we think about defining cohorts and measures and all the stuff that goes along with that. So CQL is a great framework for that. It's getting a lot of traction. We have NCQA defining HEDIS measures in it. We have the US CMS publishing ECQMs, DCQMs in this, and just more and more usage of the standard, and FHIR taking on the NCQA CQL engine as part of their open source portfolio. So really exciting stuff. We like CQL because it gives us a nice place to talk about, to bridge between medical concepts and the data as it sits. If you try to think about a cohort for a surgery, this is something that was drilled into me by informaticists at Mayo. I live in Rochester, Minnesota, and I run into the Mayo folks quite a bit. And they sat me down and said, all right, so we want to look at surgeries of this kind that were preceded by someone being given this medication. And then after the surgery, within 30 days before they had this medication, and within 90 days after they had these two complications. And each of those statements by themselves is pretty hard to evaluate. Like figuring out whether or not somebody had a surgery is potentially much more difficult than you would want. So you've got a whole query in SQL. You have a whole subquery around just identifying what each of these events is. What is the surgery? What is the medication administration prior or medication statement prior? What are the outcomes post-surgery? And then putting all those things in this sort of temporal relationship. If you think about this, if you're familiar with SQL, you end up with sort of between statements in your joins. You end up with a lot of subqueries. It's really messy. And then you write all that out and you hand it to somebody and they're supposed to figure out what this thing does, and it's 3, 4, 5 pages of SQL. And it's really hard to reason about. So you're not sure if there's bugs in it. You're not sure if you did it right from that. Enter CQL. These kinds of constructs are natively built into it. You can look at a CQL statement, and even if you've never seen one before, you have some idea of what's going on. Certainly some of these things are a bit strange if you've never been around HL7, but if you've been around previous standards, a value set with a void, you go, yeah, I can probably figure out what's going on there. And the defined statements are relatively straightforward. So we really like it for those qualities. And what we're thinking about is we've got now 2 reference implementations out there. We've got the original one that Bryn wrote, and now we have the NCQA engine. Both of these are in-memory evaluation engines, so we have to get the data to them so they can execute the rules and figure out what these defines look like, which is really great on a per patient basis. But I work in population health at Google, and frankly, doing that for every measure for all of millions of patients is a daunting thing. We can parallelize and do a bunch of things, but really we want something that's more scalable than that. So we're thinking about how to really build a scalable CQL engine as a companion to the reference implementations that are out there to give us more tools in the tool belt. Actually, go back. I'll say one more thing about that. The end goal of this, or not the end goal, one of the places we think this can go, though, is how do we reduce the amount of input, the amount of definition necessary to do useful things with this data? If you have to think about the end schema, like, okay, so how do I flatten the data? And then how do I measure the quality of the data? How do I build quality measures around that and decide whether or not my data is adequate to run this measure? And on and on and on. It becomes very, you need an analyst, you need an engineer, you need quite a bit of effort to go from data sitting there, like I've solved the interoperability case to some extent. I've got the data sitting in a FHIR store, but to get from that to I can actually run a measure or I can actually analyze a cohort, still today is a pretty daunting journey. With this, we're hoping to say, no, we can reduce that to, you tell us what your problem is in CQL, or we'll do something to help you even generate CQL, and then we will try to figure out, can we do some useful things after that? So that's the space we're exploring right now. Can we get to a much easier to use, more direct kind of workspace using this solely as the input? So I think I've covered all this. Let's just jump over this. Oh, Does someone have questions on that? No? Okay. Well, we got lots of time for Q&A, and this is billed as an introductory talk, so we're happy to dive deeper into any particular area. But Erik?
Yeah, so kind of what we have here are really a consolidated list of the lessons we've learned as we've tried to deploy analytics, AI, and ML in the field. These are somewhat prioritized, but not entirely. And again, this is just, again, during Q&A, dive into each one of these. These are our experiences, curious about others as well. And I've already harped on the first one, kind of in the earlier part of the presentation, of just, we learned the hard way that you gotta know your use case, especially when it comes to getting your data mapped from source systems into FHIR if FHIR is not its native state. Because we've seen kind of customers and folks in the field go about analytics implementations a few different ways. Kind of one is, let me just get all my data into a FHIR server first and figure out what to do with it later. They spend so much time kind of on that ingestion and an understanding what data they actually have in there. By the, that's the long pole item of a lot of analytics projects, of just getting the data in. As opposed to kind of working backwards from that, of identifying and understanding what business problem you want to solve first. It lets you be selective throughout the rest of your implementation. It lets you understand if I'm looking to optimize patient flow, and kind of the demos based around this, what are the key elements and metrics that are part of that use case, part of that user journey? All right, now let me go grab those first, get them into my FHIR store, optimize for those to increase performance and scalability, and then worry about the rest of my data. But so it all starts with knowing your use case, which is also how you help customers kind of increase their time to value, increase their ROI of their investments. This transitions really nicely and partners really nicely with understanding data usage patterns, because similarly, we want to onboard and kind of work with and optimize priority data. And so kind of what are those metrics that we're using most? What fields are we referencing most? What are those usage patterns? Now let me optimize my analytical schema for those because they're the most commonly and most targeted fields. Driving insights through everyday reporting tools. One thing that we were trying to do is not recreate the wheel for customers. So a lot of folks, when you go on site or as we start helping them through this healthcare digital maturity cycle, they already have enterprise platforms stood up. They may be Tableau shops, they may be Looker shops. And so kind of the onus is on us as technologists to not only build new technology, but make sure that technology fits into the workflows, the existing workflows of customers, and not saying, hey, here's this really cool thing, but you have to kind of shift your entire infrastructure kind of, to make this work. So leveraging existing technologies, especially when it comes to analytics, AI, and ML. And then simplification through data manipulation. This really hits analytics, reporting, and AI. You unlock those three things through data transformation in a lot of ways. Like, yes, you need your AI and ML models to be tuned and tweaked. You need to enable uptraining, all those things. But if your data is not structured the right way, especially when it comes to FHIR data, which, because we've talked about, is just nasty to deal with, you reduce the business value of analytics, AI, and ML. One thing we've also found very powerful is leveraging your analytics warehouses, bringing in third-party data sets to enrich the FHIR resource, enrich the FHIR profile. We're doing a lot of work with this in around social determinants of health. So kind of right now, there's only so much data within that FHIR profile, but if I can enrich that with third-party data sets, I unlock tremendous additional value on top of that for different consumers. And then skipping over that last one, because we touched on it, really the 70-30 rule of data optimization. This goes back to point number 2 of understanding your usage patterns. As we all know, when it comes to enterprise reporting, AI and ML, kind of the powers in the data, and we need to optimize that. And so looking at your usage patterns allows you to understand, where do I invest in maybe materializing views, indexing different tables, because you probably can't do that across your entire data source, especially when you're at the enterprise level with hundreds of different data inputs. So building for the masses, optimizing for the masses, and then kind of letting and helping the customer tune and tweak for that last 30% to make it unique to them, just because every customer is different. We've seen kind of success around in terms of building products and building platforms at scale. We have 5 minutes. Okay, so let me pivot over quickly. So what we're going to showcase now is something that we actually, if I can find the right tab, have live in the field. And this is all synthetic data, so nobody worry about kind of HIPAA or anything like that. Pretty basic dashboard. Call this Patient Flow Explorer. What this is meant to emphasize and highlight is different efficiency metrics within a hospital, within a series of hospitals. And while this is just a simple dashboard, what's happening behind the scenes is actually combining a few of the different techniques that Chris walked through from a tech standpoint. So we're leveraging Looker as a front end. So we talked about leveraging existing reporting solutions out there in the field. You could also slap a Tableau dashboard on top of this. One thing we love about Looker, and one thing we know, each of the big 3 or 4 reporting tools brings something new and unique to the market space. When it comes to healthcare, a cool thing that I found out pretty late in the game is that Looker actually can query the FHIR schema directly, which is really, really neat. So you kind of can circumvent some of the needs to flatten that data and make your FHIR data rectangular, as Chris mentioned. But what we're doing here is this is sitting on a series of BigQuery flattened tables, which Chris went over, as well as semi-flattened tables. And I'll show you those BigQuery schema here in a moment, which is projected into BigQuery via SQL on FHIR. So kind of there's technique number 2, and everyone knows a lot about that standard. And then we've also introduced the concept of, in the length of stay, how that once you get that data structured in a correct way and move that into a BigQuery or analytic reporting environment, you can sit ML modeling and AI tools on top of that and feed those back into a reporting platform or into a reporting solution. And so without getting too far into the weeds, again, I won't take you through every metric here because again, it's just a dashboard. But what we're showcasing here is by leveraging those common everyday practices that Chris covered. We were able to spin this up over the course of, once you get through the requirements gathering sessions and metrics definitions, from a tech standpoint, get something like this stood up kind of within a day or 2, and this is sitting on top of trillions of records. It's highly performant, and it's because we applied those methodologies and that kind of that hierarchy of needs that we went through earlier. So yeah, kind of, I think that's the last slide we have here. I just pivoted out my slide deck, but happy to answer any questions about any of the content we covered, anything here. Kind of just remembering that this is about how do we take everyday techniques that everyone's more familiar with that aren't overly bespoke to FHIR, and you can drive real impactful customer results with them. So with that, we'll move to Q&A.
Yeah, so thanks a lot, Erik and Chris, for your wonderful presentation. If there are any questions in the room, please raise your hand and I will bring the mic to you so the people in Zoom can also listen in on your question. So are there any questions from the room? None yet? Well, actually, I do have a question, Erik. I was wondering, in hospital data, there are a lot of doctors who are also doing research and they want to publish their research results. And for that, their data needs to comply to the GDPR, and there is mostly strictly rules apply for use of that data because it's patient data that may be personal identifiable. Now, personal identifiable data is not in one column. It's usually the combination of columns that makes a person identifiable. And I wondered if you could give your opinion on the risk of this in your analytics of these vast amounts of data that you're using.
Yeah, it's something that you always have to watch out for, and especially as everyone here will understand, kind of in healthcare, especially as we start moving information into the cloud. Security is number 1, privacy is number 1. And so, we are kind of incredibly critical and very kind of diligent with understanding the rules around de-identification and making sure that we de-identify at source so that kind of throughout the entire workflow of that research, whenever getting ready to publish, that we're protective of those kind of primary HIPAA identifier components. And so, with us, as you saw in that dashboard, we use a lot of synthetic data that's statistically representative of source data sets. So there's mechanisms of doing that, which protects us from a lot of kind of those challenges, but also just leveraging de-identification tools and just over pivoting, to be kind of, it's better to be safe than sorry in this, and erring on the side of caution when it comes to making sure that your data is secure and compliant.
What I'd add to that is that putting data in a in a flattened view or in analytics, it's not fundamentally different, right? Like you have to protect this information, whether it's sitting in a Firestore, whether it's sitting in source files coming to you, or whether it's sitting in a database. So being able to tie those things together and say, all right, so this is the information that we would restrict coming out of the Firestore, and we also will then therefore want to restrict it in our analytics environment, and being consistent across those environments is something that we think a lot about. In fact, creating interfaces or creating that consistency, I think is a core. How do we apply consent? How do you apply, if you're in the US, safe harbor rules between your REST APIs and your analytics environment, and how do you do that in a way that you can feel confident that you've done the right thing? So that is definitely something we think about. Like, how do I make sure that if I've given the right configuration, if I've defined what information it is I want to protect and how I want to protect it, that shows up in each of the ways this data shows up.
Yeah, thank you. Thank you for your reply. I have another question coming in from Welva. The question rings, I would like to know the steps you took before you started writing SQL queries on the data.
Me feel?
Sure. We probably can't ask a follow-up to that, so I'll make some assumptions in terms of the steps. So the steps we took before we started writing SQL queries on the data. I think there's probably a few different answers to that, depending on kind of the flavor there. I'm going to go back to the lessons that we've learned here, which is before you can before you should start writing extensive and investing in extensive SQL queries on the data, understanding what you're trying to solve for. And so the dashboard I showed you, I said we stood that up in a day or two. What you don't see are the 2 to 3 weeks to month or 2 months of requirement gathering that take place before you can actually have that end result, where you're sitting down with customers, and not just one customer, but multiple customers, to understand common definitions of metrics, identifying again what that use case is, why you're solving for that use case, the return on investment that the customer is going to get when they deploy that use case. So there's a lot of pre-work that goes into understanding your data before you can actually start publishing it externally and putting it in the hands of an everyday customer. Because once data is in a dashboard and that's out there, that becomes their source of truth. And so there's a lot of pre-work that needs to be done to make sure that that data is accurate, representative, and actionable before you can actually publish data sets and publish dashboards externally or to even to your internal user bases. So that's kind of my interpretation of that question, or at least from a product standpoint, doing a lot of homework up front to know why you're querying and kind of to help guide that query journey. That's what I spent a lot of time on before kind of getting my hands dirty.
So from a technical standpoint, I'll answer the same question. If you get the data, so originally, we spent a lot of time thinking about ETL, get how you get the data out of an HR, how do you get the data from claims feed. We're seeing bulk FHIR, we're seeing some of these things come online, which is great because we start with FHIR data then, and we don't have to do some of those steps. So that process is accelerating. We use our Firestore as a source of truth, so the data ends up in a Firestore. So if we're doing mappings, it gets there. And then from there, the projection from Firestore to these flattened views or to something is something that's built into these products. So you say, this is what I want it to look like, and the product itself does that extraction. So most of the time is spent getting the data into FHIR, mapping it, harmonizing and doing whatever quality remediation you want to do. If it's already FHIR, you're off to a good start, and the SQL queries can follow quickly after that.
Yeah, there's a follow-up on this question. It's about, he adds, taking data out of a FHIR server. I believe I can't write SQL inside a FHIR server. So the question is basically, how do you get the data out of the FHIR server using SQL queries? Yeah,
so in our product, that's a click box option. You check, export to BigQuery as one of the options, and you get a SQL on FHIR projection managed for you as part of that. In other cases, you would have to think about, how am I going to get the data across to a SQL representation? Is this something I use a subscription for, where I stream data across and do a transform to get it into that rectangular shape? Is it a nightly export? Is there some sort of other unloading mechanism? Or do I have a FHIR server at all? Do I start with ND-JSON files that came out of a bulk export and just directly transform from there? So there's lots of pretty well-worn paths in the ETL data management space to move this data across. But in our environment, it's literally a checkbox.
Yeah, and we leverage BigQuery intentionally, and kind of this goes beyond just GCP and some of our product offerings. Just generally kind of use the tools that were built to do a specific thing. And so if you have a FHIR store, that may not be the most performant way to query or interrogate your FHIR data, versus if you are building out and looking to kind of do a bunch of data manipulations, transformations to feed or answer analytics questions, pump that data into an analytics warehouse that's optimized and tuned for that specific business purpose, and let the power of the kind of reporting engine run. So it's one of those, just because you can do something doesn't mean you always should, or there may be far better ways and optimized ways to perform that task. And this is kind of the power of merging these tools together, is that you get to kind of reuse things that were built for, for a specific use case.
So, question up here.
Thank you.
Chris, you mentioned SNOMED and terminology a bit earlier. Do you have any particular patterns or for projecting terminology data into BigQuery, or specific support for working with terminology?
Yeah, so the SQL on FHIR standard addresses it somewhat by providing a framework for value set expansion. That's about as far as it goes. As you know, navigating SNOMED is a substantial challenge, and that's not our goal in all of this. Our goal is to make it operational. So the value set expansions is what usually we find the most useful in that.
Thank you. Are there more questions?
Hi, thank you both for the talk. I'm curious, are there any kind of consensus standards, either in healthcare or not, on how to take something heavily nested like JSON and flattening it? Like, for example, if you have an array of things, there are multiple things you could do for your data model, like add more columns or delimit it somehow. So yeah, any thoughts on that?
So that is the thing we're talking about in our SQL on FHIR working group. Most of the databases now have unnest or flatten or some sort of function for these kinds of things. So it's pretty well understood and well supported in database tools. But as far as picking exactly what you should do, I think that is the big open question. And my point of view on this is that it's not necessarily helpful to say this is the way it should be flattened. What's more helpful is to say, this is how I want to define my use case, and can you do something useful for me based on that? Or do I have to be a data architect and figure out what the columns in this table should be? I think that's less helpful or less productive over time.
Yeah, it goes back to kind of that scale that I talked about earlier, kind of fully flattened versus fully nested. We are actively right now trying to figure out where that line is, or if there's a line. And to Chris's point, it's going to be very specific to customers' needs, but I think you hit on a few things there. It's like, do I want 1,000 rows, or do I want 1,000 kind of columns per patient? The answer is going to lie somewhere in between there, based on how the customer is going to be using that data element. And it's just funny you ask, because this is something we've been in FHIR drills around for the past few weeks trying to optimize for. So we'll next year we'll report back on our findings based on these efforts.
Great presentation. Thank you guys so much. Question. You mentioned earlier the average everyday SQL user. There's also the average everyday EHR user. Is there any feedback loop back to the EHR source systems for any of the findings or insights that are derived from this pop health or community analytics? And have your users asked for any type of specific pushback to the EHR? And what could that look like, other than like a smart on FHIR integration?
Yeah, so smart on FHIR or CS hooks, I mean, that's kind of the paths back into the EHR right now, or generating something that sits alongside in some way. But yeah, that's the biggest gap in all of this, right? So think about population health. We want to stratify risk. We want to figure out which patients we should be looking at, what gaps they have. How do you get that in front of the people that can action it? And the EHRs have, a lot of them have their own solutions. So if you're using their solutions, you have a path back sometimes. If you're building your own, it's much more challenging. which is why we see a lot of CMS, sorry, not CMS, CRM kinds of solutions sitting beside the EHR in order to manage these things, because it's very hard to get these insights back into the EHR. So yeah, I think that's an area that will continue as these things, again, we're working on just getting the data, right? And as we get past that, now we get to, how do we define the measures? How do we define the guidelines? And kind of the next evolution of that is then how do we make them actionable? So I think that's what we're going to see DevDays in, a few years being, shifting to that. But CDS hooks, started with that sort of thing in mind on a very small scale.
Yeah, I mean, the problem statement is there and the need is there. And so kind of in that, one of the early slides where I was showcasing some of the things that we're building out, one of the problem statements that we're building against right now is not only how do you write back to a source EMR, but how do I write back to an existing FHIR store based on the output of an AR ML model? What does that look like? And this goes back to, again, one of the main reasons we're all here, which is how do you standardize these things so that they're consistent? And so, again, all very good questions and all problems that we're actively trying to tackle and figure out on the fly here. But there's a strong need for it, especially as this Gen AI push wave continues to rise. It's the hot topic issue. So every hospital CEO is like, okay, how do I get my hands on Gen AI stuff? It's like, well, you can get your hands on it, but how do you finish that? How do you create that closed feedback loop back to your source system so that it's not just kind of a linear workflow? So yeah, strong demand and kind of actively working on scalable solutions.
All right. There's time for one last question, and there's one on Hoover. Praveen asks, how would you handle various versioning of FHIR resources, or how do you get to know the updates when these updates related to resources are available?
You want to go first, then I can go, or I can kick it off?
Yeah, so right now you don't. This is the short answer. Adding all these state versions to your projection obviously vastly increases the amount of data that you're dealing with. But there's nothing stopping you from doing that, especially if you're streaming data and can pick up those changes as you go. So there's nothing stopping you from having a table that has not just the identifier but the version on it, and you can kind of go from there. But typically what you're looking for then is the changes themselves. And then that's a whole nother layer. How do I do a diff between version 1 and version 2, look at that diff, and then analyze something meaningful on top of that. So yeah, I think that's we haven't found enough demand for that to have a general solution for that, because the use case, it's so important what you're actually trying to get out of that. What are you trying to analyze as things change? Most of the FHIR resources, if change is really important, they have a history on them already. So Encounter has a encounter history for all the statuses. So we've, HL7 and the working groups have gone through and said, is change important? Oh, if it is, let's build it right into it. And then beyond that, you really have to customize for that specific thing.
All right. Yep. Thank you very much, both Chris and Erik, for your wonderful presentation. Everybody give a warm applause for these two gentlemen.